Hello there and welcome to Lower 6 Further Maths A-Level January Mock Exam Revision Sheet 3. We're working on question 6, a series question. So we're looking to simplify this series here into a formula that looks like this. So first things first, I'm going to expand the brackets of what I have for my series. So that would be r cubed plus 2r squared plus r. And then what I'm going to do is I'm going to split up these individual series so that I can then use my formulas. So it's the sum from 1 to n of r cubed plus 2 lots of the sum of r to n, r equals 1 to n of r squared, add the sum from r equals 1 up to n of r. Okay, so now we use our formulas. So the formula for r cubed is n squared over 4, n plus 1 squared, add 2, and then the formula for r sum of r squared is n over 6, n plus 1, 2n plus 1. And the formula for the sum of r is n over 2, n plus 1. Okay, so now what we've got to try and do is send it this way, into this sort of formula. Okay, so factorization is going to be important here, and the first thing I look to do in a factorization is to create common denominators. Now I've got 4 here, a 6 here, and a 2 on the bottom here. I think the most common denominator I can create out of that is a 12. So times in the top and bottom here by 3, you get 3n squared, n plus 1 squared. So I'm creating the equivalent expressions for all three of these terms here, here, and here, just with the common denominator of 12. So this 2 over 6 here is now going to be a 4n over 12. This is going to make it a lot easier to factorize later on. And for this one here, if it's over 12, it's going to be 6n over 12, n plus 1. Great, okay, so now that we've got a common denominator of 12, I'm going to start to factorize. So over 12, we've got n in each of these expressions and n plus 1 in each of these expressions as well. Okay, what we're going to do next is factorize what we have left over. So it would be 3. We've got an n at the front here, but we need another n to make an n squared. And we also need another n plus 1 in here to make an n plus 1 squared. Okay, factorising the second bit, we need a 4. We've got the n plus 1, so it's just 2n plus 1. And for the third bit here, we need a 6. We have the n, we have the divide by 12, and we also have the n plus 1. So that's all we need for that bit there. Okay, so now expanding the bracket of what we have here, we're going to get 3n squared plus 3n plus 8n plus 4 plus 6. And simplifying this, we're going to get 1 over 12 n plus 1 times by 3n squared plus 11n plus 10. Okay, so what we're going to get here is I'm thinking a 5 and a 2 if we factorize this. Yeah, so let's do 1 over 12 n plus 1, and then factorizing this quadratic here, we're going to get an n plus 2. I suppose the clue is in our answer here, and the remainder here is going to be 3n plus 5. Let's just check the 11. Yep, that works. Okay, so here a is the value 3, b is the value 5. Excellent. Okay, so that's part A done. Part B asks for us to find the value of n such that this summation works. Okay, so on the left hand side, we're going to have, as we had before, n over 12, n plus 1, n plus 2, 3n plus 5. And on the right hand side, we're going to have the formula for the series of 70 and times the sum of r. So it's going to be 70 n over 2 n plus 1. So what I've done here is I've used the formula for the sum of r and just times that by 70. Okay, so now we have a formula here and we need to work out which value of n this formula is going to work for. Now I'm going to cancel out n's on both sides, given that n is non-zero. Cancel out n plus 1's on both sides, and all of a sudden I have 1 over 12 n plus 2 3n plus 5 equals 70 divided by 2 is 35. Okay, so times up by the 12, and we're going to have 3n squared plus 11n plus 10. So expanding the brackets of those double brackets there. And we're going to get times up by the 12, and we're going to get 420. Okay, so next coming up, we're going to need to take the 420 onto the other side. So 3n squared plus 11n minus 410. Okay, so now we need to think of a genius way to factorize this, if we can. So 3n and n, it's going to be n minus 10 and 3n plus 41. So either n is going to equal minus 41 over 3, not likely because n needs to be a positive number, or n equals 10, very likely it's a whole positive number. So therefore n equals 10 is our final answer there. Okay, 8 marks for that question.